believe it's page 5 in your packet. Let me see if that's correct. It is correct. Nice. So covalent bonds, Bellwork. This is picking up where we left off on Friday. Now, the first few questions, a little bit lower hanging fruit. They're not too bad. And they're also positively fair game on your quiz this week. Okay? Remember, we have a big old fat quiz tomorrow that is worth just over 30 points. 3-0. A little over, a little north of 30 points, okay? Now, some of the points are a little bit easier. They're going to be questions just like this. What are ionic bonds? What types of elements do they form between? Are they between metals, non-metals, some of both? You also want to be able to talk to me about what's happening with the electrons. Like, in an ionic bond, what are electrons doing? In a covalent bond, what are electrons doing? That kind of thing. You should also be able to draw the Lewis structures of individual atoms, like an Se or an F by themselves. Let me see here. And let's talk about a Lewis structure of one of these compounds. Okay. Let's take a look at CO2. Again, you should do the problems at the top, but let's take a look at one of the ones on the bottom together. So, which of these elements do I want to start with in the middle? Between carbon and oxygen, which one do I want to start with? Carbon, why? Yeah, it has 4 bonding sites. It wants the most valence electrons. And so, if you ever have carbon, you can immediately like, boom, yep, that's what I'm starting with. So I got my carbon. It's got 4 valence electrons. Boom. I got oxygens. Here's one. It's got 6 valence electrons. 1, 2, 3, 4, 5, and 6. Notice how I'm kind of pointing those bonding sites, that is, those single electrons, towards each other. So I got 1, 2, 3, 4, 5, and 6. So, just a little review. These guys right here, those are a lone pair of electrons. When you have 2 electrons, those do not participate in bonding at all. You should never move those for any reason. You should never draw a line for a bond using those guys right there. Okay? The only electrons that are used in bonding are the single electrons, those bonding sites. Okay. So, I have, let's see here, I got 6 valence electrons from the oxygen on the left, 4 more from the carbon in the middle, so that's 10 total, plus 6 more from the oxygen on the right, that's 16. That means I have exactly 16 electrons, no more, no less, to make all 3 of these atoms happy, okay? So, right now, the carbon has a single bond to the oxygen on the left and the right, but it still has 2 open bonding sites here and here. So those need to be filled with a bond. So I'm going to go ahead and I'm going to move this bonding site on oxygen and this bonding site on carbon to here and here. This oxygen now has its 8 valence electrons, so it's happy as a clam, forming a double bond with that carbon. Carbon, though, is not happy yet. It only has 7 valence electrons, 4 on the right, 1 on top, and 2 on the left. This oxygen on the left is also not happy. Not to mention they have open bonding sites, which is the big no-no. All bonding sites need to be taken care of. So I'm going to move this bonding site and this bonding site to here and here. So now oxygen on the left is happy because it's got 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. And this carbon is also happy. It's got 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So notice I still have exactly 16 total electrons, but I also no longer have a single bonding site left over. Every now and then I'll see people with a final answer that looks something like this. It'll look something like this, where they have like 2 dots here, and then they got 1 and 1. And they're like, oxygen has 8 valence electrons. We're good to go. What this means is they used a lone pair of electrons for bonding at the beginning of the problem, which is a big no-no. You should never have single electrons like this left over in a problem. Those are bonding sites. They need to form a bond before the problem's over. So if you ever have something like that, you know that you use the wrong electrons to form a bond. It should only look like this. Okay? So I strongly encourage you to start at the top of this bell work and then get to these Lewis dot structures, because you do need to be able to answer these first few questions, because those will certainly be the types of questions I might ask you on your quiz. Okay? So we're going to give you guys a handful of minutes to work on this. The pink sheet on your desk is the answer key, or if you're watching this video recording, the answer key to this is right below the video. I'm going to give you guys several minutes. Get cooking. So hopefully this bell work's going okay for you. You will absolutely need to be able to draw Lewis structures, and a lot of them, to do well on that quiz, okay? So as a huge part of that quiz is drawing Lewis structures. Now if you want to go ahead and flip a couple of pages to page 9 in your packet, so this is page 9, the Molecular Models and Lewis Structures worksheet, page 9. Man, writing page numbers on that packet, that was clutch. Not my idea either. Got a couple of students said that to me. I was like, that's a really good idea. So page 9. Okay, so we're going to start busting out model kits. Now, if you're watching this recording, it'll be a little hard for you to see the model kits, obviously. But that's what we're doing here in class today. So tomorrow, I may ask you on the quiz, I may show you a model. Like, there's models built around the room. I may show you a model, be like, give me the Lewis structure, give me the formula, draw this for me. I may also just be like, hey, here's a formula. I want you to make the model and draw it and do all kinds of stuff. Okay, so it's a two-way street here, where you may have to produce the model, you may have to interpret the model, but you're going to have to be very familiar with compound models. Now, H2O. There's a couple ways I could do this. Okay, so I'm given the formula in this particular case. So if you guys pop off the lids of those model kits around your desks, this class is small enough that you guys can all have your own individual one. On the inside of the lid, you will see a key, so you want to flip the lid upside down, because the lid gives you a key, or like a legend, for what the different colored atoms mean, or which one's which. So the black ones are carbon, for example. You'll notice you have more of those than just about anything, because they're really common. So we've been tasked to build H2O. Here's what you can do. You can go ahead and just go straight for the model and build an H2O. Other people find it easier to draw the Lewis dot structure first and then go make the model. Totally a preference thing. Personally, I like drawing the Lewis dot structure first. And I'll show you why. So if I'm going over my Lewis dot structure, between H's and O's, who should be in the middle? Oh, definitely O. H's are never in the middle. They can only form the one bond. So I'm going to go ahead and get my Lewis dot structure. So I'm like 1, 2, 3, 4, 5, 6. Okay. And I got an H over here. That H is happy with 2. Got an H over here. That H is happy with the 2. Sorry, Kwame. And this oxygen's happy. Now, here's what's obvious to me after I make the Lewis dot structure. I'm sitting there looking, okay, I have 2 bonds. So oxygen has a single bond to a hydrogen on the left and a single bond to a hydrogen on the right. So I go to build my model. I should just have 2 bonds, 2 single bonds to different hydrogens. So oxygen's red. And you'll notice oxygen only has 2 holes in it. Why is that? Why does oxygen only have 2 holes in it? Yeah, it only has 2 single electrons, 2 bonding sites, so it's only going to form 2 bonds. Nice work there, Maddie. Okay, so I put those bonds in there, those little wooden sticks. I pair them into hydrogens, which are yellow, and here's what my model should look like. Mr. P, why is it bent? That's a great question. Hold that thought till we get to Vesper, but that'll be explained as well. Okay? So here's what my model looks like. So on tomorrow's test, if you were to pull out H2O out of the hat, you'd have to be able to make this model for me. Okay? You'd have to be able to make that for me. Tomorrow, you can use your own periodic table. You can always use your own periodic table unless it's a unit test. But you can always use your own for any other situation. Now, when it says draw the model structure, Notice what we're going to leave out. You are going to draw only what you can see. Okay? Can you guys see the lone pair of electrons that we know are on the oxygen? No, you can't when you make the model. All you can see is this. I'm going to draw. I got an O, bond to an H, bond to an H. That's all I can see. That's all I can see. And some people like to draw that a little bent. That's your prerogative. You can totally do that if you want. Gets a little trickier when you get to CH4 in the next problem. You'll see what I mean shortly. So I just want to clarify, you don't need to draw the lone pairs of electrons when you are doing your model structure, but you do not want to forget them when you're working with your Lewis dot structure. So this guy right here. So you need to have these lone pairs of electrons right here and right here on oxygen to get your full credit. Okay? Now, for the rest of the period, you guys are just going to work through this worksheet. It's front and back. It takes a while. You're going to make all the models, draw the Lewis dot structures, draw all the models, okay, when you're given the formulas. I will say that the random compounds that you could draw out of the beaker tomorrow on your quiz, the usual suspects for that are the ones on this worksheet. Does that make sense? By doing this whole worksheet, you could easily do the problem that you're going to be asked to do tomorrow when you pull one out of the hat, okay? So I'm going to come around and check in on folks. Let's get her cooking. If you're watching this recording, I can send you a few pictures of model kits if you want to kind of give you a visual. Just shoot me an email, but let's get her going. Okay, so now that you guys have gotten kind of familiar with building the models from scratch, if you take a look around the room, there are a bunch of stations with models already made. So tomorrow, what you're going to do is you're going to go to a ready-made model. You're going to figure out what its formula even is based on the model only, which isn't too bad. That just kind of, it has 3 yellows, that's 3 hydrogens, a blue is a nitrogen, that kind of thing. And then once you get the formula, then you're going to make the model drawing. Then you're going to make the Lewis dot structure. Okay? So on the quiz, things that you need to be able to do. You need to be able to answer questions like the beginning of bell work. You need to be able to draw individual Lewis dot structures. You need to be able to draw compound Lewis dot structures. You need to be able to make models. You need to be able to interpret models. Okay? So on your quiz, you'll draw a model out of a beaker, and you'll have to draw everything about it and make that model. But you'll also be handed a ready-made model, and you're going to have to interpret it as well. The last thing I'll mention about the quiz, which is the really good news, we've pushed it back a day. So we're going to make this 30-plus point quiz on Wednesday. So that way you guys have plenty of time to finish up this if you didn't quite finish up today. To go to all the stations tomorrow and make sure you really understand them. And we'll have we've cooked up another bell work for you for some extra practice. Okay? So quiz pushed back a day. Don't get used to that. That usually doesn't happen. But this particular one, since it's pretty juicy, again, it's over 30 points, we pushed it back a day. So, good stuff today, folks.